Monica, you can speak. You can start now.
Yeah, sure. Ravishankar, are you ready?
Yeah, yes. Chris, can you hear me?
Your voice is a little low.
Am I audible now?
Yeah, it's better now.
Yeah, that's all right.
So,
Okay.
yeah, you can start, Ravishankar.
Yeah, yeah. Thanks.
Ravish, please stop sharing. You can share your screen.
Yeah, I'm sharing my screen. So, yeah, it's a good evening to all. So, I'm Ravishankar. I'm working in Verizon as an architect for the past 5 years. So, I have total experience of 13 years in IT. So, I worked on as a developer and full stack. So, and I'm now basically involved in cloud and Spring Boot related application and architecture of those in Verizon. So yeah, so the topic now today is edge computing. So that is something as a talk of the town now. We are hearing about the edge computing everywhere after the introduction of 5G, and we'll see what is that we are lacking in the cloud. So that kind of topics we'll see. So these are the short overview of what we are going to see in a very high level. What is the cloud and what we are doing with cloud now? So what is the need that the the customer or the enterprise is required apart from the cloud what we have right now? So and then the architecture of edge computing, the high level, how the edge computing works, what are the components of edge computing, and what we have in the edge computing, the terms of edge computing. So third one is the impact on healthcare. So we'll see why the healthcare is so important on the edge computing, right? So why it is the health, how it is getting impacted and benefited because of the edge computing. We'll see, and then last we'll see the different terms of the IoT and how the IoT plays a major role in the healthcare and what we have currently in healthcare and what we have currently in healthcare and how it got benefited using the edge computing. A more detailed view of the IoT and the healthcare. We'll see that one. So this is a very rough and high level of cloud computing architecture, right? So because we all well aware of the cloud computing, we are into the cloud now. So we know what the cloud does for us, and we know end to end what the cloud services is providing. There are different cloud service providers like AWS or Azure or GCP, right? So they all provide the same services to us. So all the IoT devices or the enterprise applications, everything into the cloud now. So and when it comes to the IoT, so we have a lot of use cases now. So the IoT is mainly using the cloud. There are smart devices we have, starting from the television, the fridges or washing machine. Everything is internet connected. So we have everything. So but still we are lacking something on the cloud. So we have the IoT devices which get connected and connected. So we have everything response to the customer, and we are lacking something on the cloud. Cars which talks to the IoT devices inside the car, which talks to the cloud. So we have everything, but still we are lacking on something. That is what the response time, right? So the need for speed, what we are expecting. So when we are traveling in the car, so if there is a smartness enabled in the car, so how fast that we are getting the information back from the cloud. So that is where the computing here. So when it is a refrigerator enabled with the smart services, so how soon the refrigerator is giving the information and analyzing the data, and giving it to the cloud and then getting back the data and response to the customer. So that is what we are mainly looking into it. So there is a need of high speed response when it comes to the IoT devices. The device is very small. We have different category of IoT devices, which is right from the digital capsule, or if it is a hypes in the factory or in the medical equipments, right? So there are different category of IoT devices, but all requires the speed response. So that is where the edge computing comes into the picture. So not something which popped up immediately. Right? It's been there for a very long time, but there is no equivalent technology to support the architecture of the edge computing. So usually there are different terms in the edge computing. For example, we call it as a fog compute. So and then there is a edge computing, and then we are calling another term as a multi-access edge computing. So these are all the different terms. So it is not something alternative to the cloud. This is more of an extension to the cloud. So when you say that edge computing is not going to replace the cloud, so it is more of the extension of the cloud. Say, for example, consider the big delivery ship that Amazon is building up. So that ship cannot go in all the places and deliver the product, right? So that ship will pass few drones to the different areas and deliver the product, and then the drones will get some information or just get back to the mothership. So something to put it in a very simple way. So that is what the edge is. So the cloud, the which will get some information or just get back to the mothership. So that is what the edge deploy different edge nodes to the edge node will perform certain options. So this is very to go in deep, right? So this is the only definition of edge computing. No, it is not. So the edge computing will differs in different scenarios. So, for example, if you take the IoT device, if you take the multi-access edge computing, call it as. So there are few scenarios that computation will take place on the device. This is a one edge computing. So there are few scenarios that computation will take to the nearest location. That is the edge computing. So instead of going to the cloud, the nearest possible area that computing will take place. That is a very precise ways to put what the edge computing is in a very theoretical manner. So what are the we'll see the use case and we'll go how it's getting implemented in the real life, right? So what are the different use cases? What are the need of edge computing first? So if you take different scenarios, like we have video streaming apps and video analytics, and we have related smart cities or smart homes, even the smart hospital now we are calling it as. So we have augmented reality applications, and we have content catching, and then hyper personalizing the content based on the location or based on the customer. So these are the different use cases we have. So how what is the need? We are having enough apps for the video streaming like Netflix or Amazon Prime. So we seeing seamless video, right? So, but what more required? So, but the question is, are we getting the full time HD content that is streaming in the mobile? No, they are doing a lot of works behind the scenes by modifying the quality of the video and use it for the seamless experience. So how we can avoid this kind of complexity?
Ravishankar,
So let's say, yeah, yes, Monica.
your voice is breaking, so it is not clear. Your voice is breaking, Ravishankar. It's not clear. I think there's some
Okay,
delay in the
let me check.
connection.
time. So we have, the question is, are we getting, they're doing a lot of seamless experience. So how, okay, so is it fine now? Yeah, is it fine now?
Still, it's breaking. Like, can you speak once? Maybe like we can check.
Yeah.
Or not.
Yeah, is it fine now? Yeah.
Now it seems to be better.
But
Okay. I hope it's fine. Let me know, guys, if it's still pretty bad. I will try to connect.
now you can continue. Thank you.
Yeah, so this is what I think, this is a live experience that we are facing now regarding the quality of which will the edge nodes perform certain operations. So this is computing? No, it is not. If you take, so there are few scenarios. The device itself. That is why. So instead of going to what are the different use cases we have of the edge concept here? So and then hyper, these are the different use case we have. So or Amazon Prime. So but the question is, so you take Amazon Prime, AWS EC2 instance, right? We have different regions in that one. You can go and pick any region. So if it is in India, you have a region in Bangalore or in Mumbai. So that region you can go ahead and deploy. So the content what you hosted is will get delivered from those regions, right? Wherever the server is located, cloud server. So if you assume, like, say there is a machine very much nearer to me, right? So there is a server which is located near my mobile tower. So whatever content that I need, that is getting delivered from that mobile tower, from nearest to my location. Or there is a machine which is very much deployed in my router itself, right? So that content is cached in my router level, so it is getting delivered to me. Think about the speed that we get and the quality of the data that we'll get. So that is what the edge computing that we are implementing here now. So the content, whatever the content we are talking about, so it is about it is something which will get applied for the customer facing applications like a video streaming, the live telecast of videos, or the streaming apps or analytics app, right? So the live data analytics. So the user is performing certain data oriented operations. They are doing some, it will get immediately catched and processed in the edge node, edge server, and then the response will immediately return back to the customer, or the personalized data will return back to the customer. So that is what which applies for the edge enabled applications. So what about the IoT? So if you take IoT, it is widespread. The IoT is implemented in different areas, like right from the smart cars and even the phones and wearable devices that we have, and the home security appliances or home appliances, as well as the hospitals. So different IoT devices we have, and right starting from 1 to 2 millimeter size, and it goes to different size, right? So each IoT will have a different nature of uh, you know uh, different kind of application they do. They have the different natures and perform different operations. So why still we have the digital, for example, there is a digital capsule which is very small in size, which will get into the patients, and it will spread, the sensor will get spreaded and get activated on the stomach acid, and then it will send the signal to the patch that applied to the patients, right? So that patch will again transfer data to mobile, any, and then it will signal Bluetooth connected device. It may be a mobile or desktop. So and then from the desktop it will be pushed back to the cloud server. So there is a lot of operations that are going on. The complexity of information, travels of information is going on. So again, the response time that it takes, it will be very large, because it goes all the way to the cloud and get back here to the patient. So that is what, and then from that desktop, it will again push back to the going on. So again, will get a lot from this edge. Consider the case, right? So I have a IoT device. So I have a local nearest server which will do all the computation that is required for me, what the IoT device functionality I have, right? So I will do some operation with my IoT device. So I will do something with my IoT device. So that will just immediately hit the nearest server and get the information processed and then return the response to me. This is very much which applies for the critical IoT healthcare devices as well as the smart cards. Because the smart card, consider about smart card, you need to have the quick response. If you are having see the obstacle, this is very much to the analysis and respond to. So we'll have so many questions on this. So if you're saying we can raise a questions like it needs to respond, do the analysis. We can raise a questions like if you're saying there is a computation, what is the difference between the cloud and physical? We'll have all the operation in the land, right? So obviously we can do, but that is not the case. So as I said, yeah.
Like lost you there for a bit. Your voice was cracking.
Okay, so I was telling like, so we can for argument, not, we can ask like, what is the need of this edge? So any computation that we are doing nearest, so why can't I have my own computation which will do all these own application, or I will have my own machine which will do all the operation. Obviously we can do, but this edge computing is not something alternative to the local machines. This is something or on-premise servers. This is something the extension of the cloud. So edge computing will not only do the computation. So it will do the computation and return the necessary response to the. This edge computing is not something uh, consumers whoever are requesting for, and then it will sync back to the cloud with the detailed information. That is what that we are doing. So where it first means, so instead of I'm sending all my data to the cloud and then getting my data processed, analyzed, and processed, and then get the response back. So I will send the information to my DNS server, and then I'll get the necessary response in the local machine by extension of the cloud. So that is what that we are doing. So on the cloud, that edge server will process the data and then send the necessary data to the cloud server, the detailed information, process the data, so it answers to the cloud. So the large computation analysis will, that is what the real definition or the meaning of the edge computing. So this is the overall architecture that we are seeing now in the edge computing. So how it works. So let's say you have a user facing device. User facing. There are few terms in the edge computing. For example, user facing device will call this radio access network that I hope you're well aware of this radio access network now. So the user edge device will use a radio access network and then call the mobile edge host. That is we call as the server which we get deployed to the nearest mobile tower or anywhere. That is what we call as a mobile edge host. So who is responsible for this mobile edge host? It can be a cloud provider or it can be the network provider. So anyone can. So think in this case, right? So let's say we have a cloud provider like Amazon Azure, AWS, or Microsoft Azure, right? So uh, and we have a network provider like Airtel or they should have the partnership in place to deploy the minified or small computing servers in the in each network tower. So in a nutshell, it's like each and every network tower cloud provider like right. So mini cloud computing platform like Apple or the idea or something. So each and every mobile tower will go and have a static server, or each and every router that is deployed in the customer facing or in the business area or in the commercial areas, there will be routers, right? Large amount of routers. Let's say we have a edge server. Each and every mobile tower will go. These that is deployed. These are all called the edge nodes. So they are the smaller computing edge servers deployed edge nodes. So let's move on to the next slide. So how we'll jump into the healthcare sector now. So we'll see what is a need, a real need, and what is the benefit of healthcare, and what are the different technologies that available in the healthcare now. So this is a high level representation of how the healthcare works now. So right, the IoT, we have different IoT devices. Even in mobile, we have few health related apps or health related sensors, and also we have dedicated, like if you take the smartwatch or smart band, or if you take the digital capsules, we have a lot of different IoT devices we have. So all these devices now, they will just call using the gateway, they will call the cloud server, and they will communicate to the API of the cloud and then get the result back. This is what happening in the cloud. So but in the IoT, as I said, so we have a dedicated edge servers. These sensor or IoT devices will call the edge and do the operations, and then the data will send back. So what are the benefits we have? So even we can say, right, so let's have a more region which will we can go ahead and create in the cloud and have a very fast response APIs which will do the operation. So why can't I go and send the data to the cloud itself, right? So we can still ask this question. It is a valid one, right? So but there are few benefits in that one when it comes to the healthcare, right? So um, the speed of data transmission, right? So that is very much higher when compared to the cloud, and also the security of the data. So when it comes to the healthcare, all we do play around with the all patients data. So when it comes to the patient data, the most required thing is the privacy and security. So if I'm having some kind of personal disease or some kind of problem, so I have an IoT device. So I don't want all my data to send to the cloud server. I don't want the data to be exposed. It's not only for healthcare, for any kind of the customer centric applications, right? So that is what we require now. So um, but in the operational perspective, right? So we need data to AWS or Microsoft customer again. So that is what we are getting benefited in the because we're going to have a mobile cloud computing. Each and every router business area or in the commercial areas deployed in those areas. So small computing, so server, which will not completely transfer to the cloud server. So the target customer, and it will eliminate all sensitive data. Is it using the gateway? They will call the standard we need to implement on that and get the result back. This IoT will eliminate all the sensor or send the data to the cloud server, which required only for the basic analytics, right? The speed of data and also the security of the data. So do play around. One thing is the privacy and security. There is a for digital capsule, right? So there is a best example, and that is getting applied now on the based on the edge computing as well as IoT and cloud platform. So what the digital capsule will do? So when they invented, right? So there is a company, Proteus and Otsuka. So they are the one who invented first implemented this digital capsule technology, right? So when they implemented, the only complexity they had is the security and the privacy of the data. So whatever that data that is getting produced from inside the patient, so there are a lot of questions raised against this. So why all the data, this kind of data is getting transferred to the cloud? So that is where after the implementation, they are now moving towards the edge computing, right? So they are looking very forward to implement the edge concept to serve the customer 100% as well as protect the data of the customer. So that is what computing concept. This is one of the benefit. So another one is the experience and the response time, right? So consider there is a critical heart patient which is having the IoT device embedded. So they are just the device will keep on monitor the heart rate of the customer. So when it connected to the internet, so if something the IoT device which identified the heart rate, so it will immediately just analyze the data in the edge server and then give the alert to the customers. Not only giving the alert, as well as it will trigger the alert to the doctors also. So that is a real use case that the edge computing we are getting, right? So and then the cost, right? So when it comes to the cloud, so all these operations, whenever when it comes to the cloud, so the charge is always on the traffic as well as the amount of data there that we are sending and getting back, right? So in this edge computing way, if we have a local edge node, edge servers, which will process, so that the network traffic will be massively get reduced. So that is the way all this is in the very lower cost. So that is also the biggest advantage we gonna have in the edge computing. So after all these, right? So what about the quality of when it comes to the healthcare or any customer? So the quality of when it comes to we giving the quality treatment or experience to all different customers. So let's say a few customers located in the metro areas and there are few rural areas, villages, right? So are they getting a real benefit of this kind of services, right? So if they have this kind of services, then it will be like equality. So they are also having when we are in a rural areas, so it always tough, for us to communicate, and we need to travel a lot to reach one destination. Or if you are going to the doctor, it will be a little tough to reach to the clinic or nearest hospital and get treated for the even the small disease or health issues, right? So that is where for regular checkup to the doctors, right? So that is where the edge computing plays a major role. So let's say we have almost we have all uh, we are getting the mobile signal in most of the areas now. So if we have a head server which will do some quality of communication to us, services to us, right? So it will be easy for the people who are in the rural areas using the IoT devices or smart devices, right? So or even the mobile device. So whatever the basic health issue, they can easily get monitored and for the elderly peoples, right? So they can easily get monitored and uh, get the response and as well as communicated to their regular checking doctors, right? So that is where real benefit we're gonna have in the edge computing on the healthcare. So let me go to the next slide. Let me go to one of the different use cases that we're going to have, all right? So when it comes to IoT, so there are few different terms we have in IoT. So it's the Internet of Things and Internet of medical thing and Internet of healthcare things. So because the IoT is not only playing a major role in the customer centric, not only the wearable device or the sensing the sensors, it also plays a major role when it comes to the hospital equipment, right? So when it comes to the ECG equipment or X-ray machines or the oxygen inventory mechanisms when they have, so the even in the oxygen cylinder, right? So it all embedded with the IoT. So well, there are few scenarios we have in IoT. Like we well aware of the glucose level sensing, right? So we have diabetic checking machines now. So we have a BP monitoring machine. So the body temperature. So when it, I think we well aware of on the COVID situation, what kind of devices that we are oximeter or the temperature sensing areas. So all devices I think we are lively seeing now in this crisis. So when it comes to this one, right? So we have different devices. So these devices are performing now, and when it comes to the services, right? What are the we have different levels of service when it comes to the healthcare, right? So for example, the ambient assistant living, right? So we call it as a AAL. So what is AAL? So this is something when a person living alone, right? So when an elderly person living alone, so there is a special requirement for compulsory requirement for this OT service because it provides a intelligent way of addressing it all embedded with the patient, elderly patient. So that is where this AL we are mainly implementing the IoT and the edge computing concept. So for example, say there is a patient who's having health complications and they are constantly monitored in their home. So this level of implementation, right, the edge implementation will keep on watch and feed the data to the doctor that patient is mapped to. So even the patient is not even they don't even need to aware of what is happening, but this device and the edge implementation will keep on giving the data to the doctor and giving the alert to the doctor. So what is it? When a person living alone, right? So when an elderly person living alone, so will intimate it immediately to the notify immediately. So the immediate response will be assisted. So that we are mainly implementing the IoT, and that is what we saw So the third one is very critical, like adverse drug reaction. So now the complete or even they don't even need a device and the edge implementation will keep on getting digitalized. So when the patient is getting treated, right? So we need to have some kind of analysis, smart device, some medicine to so one next one is the Internet of Things. That is what we different IoT based patient record of the patient, right? So let's say the doctor is giving some preferring prescribing some tablet to the customer patient. So right, so they to know that this will not create any. So let me go. What you call any side effect to the patient, right? So that is where the immediate analysis is needed. So that's where the kind of analysis will get done in the immediate edge servers and then processed back to the doctors, and they can immediately notify, right? This tablet is we can prescribe or we they should not prescribe to this patient. So and also the community health care. So the community health, as we discussed already. So we have rural areas and villages, and metros, right? So what is a community? The healthcare which will interact the all level of healthcare, right? So different hospitals should not the community healthcare will interact with each. So glucose level sensing, right? So we take the body temperature. So when it's already so the temperature sensing areas, so in villages and metros, right? So that, right? So different hospitals bring their the hospital status and on the equipment. When a person living around, there is a special requirement for Internet of Things. That is what we saw. Third one is very critical. If some hospital requires something, the information get fast and get it before that kind of analysis needed. Analysis will happen on different ages, and it will consolidate all the information. It will get all level of, and it will consolidate all the process and get back to the hospital. It will share to each, and it will get processed and get back to the hospital. We have a lot of vaccinations and monitoring for the children. So the children monitoring. So information. So now I think so when the information that we are that is capturing against the children's behavior, mental behavior, or how they are behaving and what is the complexity they are having. That kind of analysis will get immediate get back to the doctors or the person who is using the apps to check the status of the children. So that is one. So the next one is a wearable. So wearable device, I think we have will have different wearable devices we have. So that kind of information will just transfer to the edge, and there are a lot of possibilities we have now in this area, right? So the person who is using the app. When it comes to the IoT, it's not really the IoT will get benefited from the edge. Because of the edge, we're gonna have a lot of uh, innovations gonna happen in the IoT sector. It's gonna grow in the parallel way. So because of this level of computation, the speed computation, so we're gonna have a lot of interactive and innovations devices gonna come up in the future. So the indirect emergency is one of vital thing. I think we have a lot of kind of IoT devices app is that. So, but on top of that, there are different scenarios like unfortunate natural disaster or any kind of accident or any SOS situations, right? Those kind of information, which if we have the immediate needs services available, so it will get processed and notified to the corresponding sectors immediately, and then get it served. So even if I have the better use case, right? So I have a device which is embedded with me. So I'm going to some place and there is I got stuck, or there is an accident happened. So that device will immediately notified automatically, get it processed, and it will monitor my status and keep on telling transfer the data or suggest the doctors to tell what happened. This is what will feed the data to the doctors and give some background information of what has happened. So that is the kind of use case we're going to have. So these are the high level use cases that we have, right? So I think there are still a lot of innovations happening to come to the edge providers, right? So we have AWS, which introduced Amazon Wavelength, and Microsoft Azure is also providing the edge cloud edge platforms now. The information that we create so which can be deployed in the cloud, and will deploy our API services in that. So get it served immediately. That is what cloud now it is happening. So I think more of a Verizon is partnership with AWS Wavelength now, AWS now. So I think ATL is AT&T is partnership with so that is uh, so there are different migrating to the so,
Ravi, we lost you
way
there
for
for
the customers.
hello.
Yeah. Yes.
We lost you there for a bit, Ravi. Can you repeat? 10 to 30
Yeah,
seconds.
yeah. So I was telling about the how the cloud providers, right? So the AWS wavelength, which is introduced, which is partnership with Verizon for the edge computing use cases. So as well as yeah, the Microsoft Azure is giving a edge platform and partnership with the AT&T. There is a strict the, you know they are coordinating with the network companies now. The network companies is playing a major role on this one. So I think we need to look forward in our perspective, so how we are going to adopt this edge computing, as well as what kind of network enhancement that we're going to have for our country as well. So this is all the overall presentation I have for this opportunity.
Do we have any questions? Like you can, if you have any questions, you can post it in chat or in Q&A box. Maybe can we wait for a minute or two? Hello.
Sure, Shakti, we can wait for 2 more minutes. If there's any questions, we can answer.